Welcome back, guys. This is part 3 of our lesson on waves. So this is the last part of the lesson. Let me get that up on screen to show with you there. So this is part 3. If you haven't seen part 1 or part 2, make sure you go back and work through those. The first thing I'm going to do in part 3 is go through the answers to the worksheet you should have been having a go at on your time, period, and frequency sums. So if I get the worksheet up now and copy that over to my Sketchpad, we can see how well you've done those. Oh, don't want that Sketchpad. I want this one. Okay, let's get the right one here. There it is. Okay, so let's just work through these questions. I'll do these in red. So question 5, to work out the frequency, it was 360 waves divided by 9 seconds, which gives you 40 hertz. And then to work out the time period is 1 divided by 40, which gives you 0.025 seconds. Okay, so a tick for the 40 and a tick for the hertz, a tick for the 0.025, and a tick for the seconds. Right, question 6, 720 waves in 6 seconds gives me a frequency of 120 hertz. The time period is going to be 1 divided by 120. I'll need to do that on my calculator, can't do that in mental maths. Let's have a look. 1 divided by 120. Oops, 1 divided by 120 gives me 0.0083. 0.0083 continuous seconds. So let's have a look. A tick for the 120 and a tick for the hertz, a tick for the 0.0083, and a tick for the seconds. Right, question 7. 10,000 waves going past a point in 6 seconds. So 10,000 divided by 6 gives me 1,666.6 continuous hertz. That's my frequency. The time period is 1 divided by my 1,666.6 continuous. I need to do that on my calculator. 1,666.666. 1 over that gives me a time period of 0.0006 seconds. So a tick for the number and a tick for the unit, tick for the number and a tick for the unit. I think what I might do is get the rest of the questions up on my screen here. So if you've marked those, I'm going to clear the screen in a second. Close that, scroll down, get everything on my Sketchpad so we can go through it. There it is. Okay. 2 waves go past the point in 4 seconds. So 2 divided by 4 gives me a frequency of 0.5 hertz. And my frequency is going to be 1 divided by 0.5 gives me 2 seconds. Number and unit, number and unit. 10 waves in 50 seconds gives me a frequency of 0.2 hertz. This gives me a time period of 1 divided by 0.2 equals 5 seconds. Number, unit, number, unit. And finally, 1 wave in 10 seconds gives me a frequency of 0.1 hertz. Gives me a time period of 1 divided by 0.1 is 10 seconds. Tick, 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 tick. Okay, extension questions. We've got a loudspeaker which is making 5,000 waves in 1.25 seconds. What's the frequency? Well, my frequency sums were the number of waves, 5,000, divided by the number of seconds, 1.25. I need to do that in my calculator. 5,000 divided by 1.25 gives me 4,000 hertz. And what's the time period of an ocean wave if 4 waves pass a boat every 10 seconds? So I'm going to have to do my 2 calculations here. First of all, I'm going to have to work out the frequency, which is the number of waves, 4 waves, divided by the number of seconds, 10, gives me 0.4 hertz. Then I'm going to have to take that number and put it into my time period sum, 1 divided by 0.4 and I need my calculator for that. 1 divided by 0.4 equals 2.5 seconds. So those are 1, 2, 3, 4 marks to be had there. So well done if you're getting those, particularly if you got those extension questions right there. Okay, so now we've had a look at how to do our frequency and time period sums. The final one, we're going to look at the final sum is this sum which lets us use our, which lets us work out the speed of a wave, how fast a wave is traveling. So to work out the speed of a wave, and we need to multiply its frequency by its wavelength. So we've already had a look in part 1 at how you can measure the wavelength of a wave, and we've just had a look in part 2 at how you can work out the frequency of a wave. So the final thing we're going to do is use both those numbers to work out the speed of a wave. Now, when we write that in a formula triangle, I'm afraid some of the letters we use for speed and frequency and wavelength are a little bit annoying. We use V for the speed of the wave. That's because we can also sometimes say the velocity of the wave. We use F for the frequency of the wave. That's not too bad. At least F stands for frequency. And then we use this funny letter here. Oh, I'll blank that out. We use this funny letter here, which is a Greek letter. It looks like an upside down letter Y. And it's actually a Greek letter called lambda. A bit like lamb or like a little sheep, and that's why we remember this formula triangle using our little mnemonic, very fatty lamb, VF lamb, very fatty lamb, speed, frequency, wavelength. So just like any formula triangle, if we want to work out a particular number, if we want to work out speed, I cover up, let's see if I can fill that circle and be a bit better. Okay, so I can fill that circle in. If I want to work out V, I cover up V in my triangle there, and that then leaves me, it's not very good at rubbing out this, so V is going to be frequency times wavelength. If I want to work out the frequency, cover up the frequency, speed divided by wavelength. If I want to work out the wavelength, speed divided by frequency. So this is another one of these great examples of a formula triangle being used to do different sums in your physics. So last thing you're going to do then is have a look at the wave speed equation worksheet that you've got there. Let's just try a couple of examples here. We're going to calculate the speed of a wave when its frequency is 300 and its wavelength is 4. Let's have a look. To work out the speed, I cover up the letter V. V is the letter that stands for speed in these sums. So speed is frequency multiplied by wavelength. So if I get my frequency and multiply it by the wavelength, let's have a look there. Frequency, oops, not very good at rubbing things out here. So I've got frequency divided by wavelength. So I'm going to have 300 multiplied by 4. It gives me 1,200 meters per second. That's the unit we measure the speed. And that's absolutely terrible at rubbing things out. Okay, so 1,200 meters per second. So I just covered up the part of the triangle I wanted to use, and then I found my number. Speed is frequency times wavelength. So 300 frequency, wavelength 4 gives me a speed of 1,200. And we measure our speed in meters per second, just like the triangle reminds us here. Okay, so when we work out the speed, it's in meters per second. When we do the frequency, it's in hertz. And when we do the wavelength, it's in meters. Another example of it, the frequency of a wave when its speed is 680 hertz and its wavelength is 0.17 meters. Let's have a look. If I want to work out something's frequency, cover up the frequency, and leaves me speed over wavelength. Speed divided by wavelength. Speed divided by wavelength is 680 divided by 0.17 gives me a frequency of 4,000 hertz. Now, don't forget, just like in any physics sum, we can have kilo or milli versions of any of these units. For example, kilohertz means 1,000 hertz. So if I got a sum here where it said calculate the wavelength of the wave, where its speed is 1,800 meters per second and its frequency is 9 kilohertz, let's have a look. Wavelength, I cover up the wavelength part of the triangle. So to work out something's wavelength, I'm going to do speed divided by frequency. But I need to be careful. My frequency is in kilohertz. So instead of doing a sum which would be 1,800 speed divided by frequency 9, Instead, I'm going to do my calculation, which is speed 1,800 divided by frequency 9,000. It says 9 kilohertz there, so that's 9,000 hertz. So my wavelength is speed 1,800 divided by frequency 9,000, so I get the answer of 2 meters. Okay, so your last worksheet attached to this lesson is the wave equation worksheet, which is going to get you to practice doing the speed equals frequency multiplied by wavelength sums. And what you want to do now is get that worksheet, work through those questions on the sheet, and you can pause the video when I get the next screen up here. Once the video is paused, you can unpause it once you've tried all the sums, and I'll go through the answers and you can mark them. So you can pause your video now. Okay, welcome back. Hopefully you've gone through the wave speed equation worksheet. Now I'm going to get that worksheet up on my screen and we'll go through the answers and you can mark your sums. Okay, so we're always going to be using that very fatty lamb speed, frequency, wavelength sum. And I'm going to try and sketch the answers on the screen here so you can check if you've got them right. Screen sketch. Okay. Calculate the speed of a sound wave, which has got a frequency 100 and a wavelength of 3.5. Okay, speed is frequency multiplied by wavelength. So I do my frequency of 100 multiplied by my wavelength of 3.5 gives me 350 meters per second. 2 marks for the number, 1 mark for the unit. Calculate the speed of a wave that has a frequency 5,000 hertz and a wavelength of 4 meters. Speed equals frequency times wavelength. So frequency 5,000 multiplied by wavelength 4 gives me 20,000 meters per second. 3 marker, 2 for getting the sum right, 1 for getting the units right. The frequency of a sound wave, if its wavelength is 17 and its speed in air is 340. So now I need to think what frequency is. Frequency is speed divided by wavelength. Okay, so speed is 340. Wavelength is 17. 340 divided by 17, pop that into your calculator, gives you 20. And because it's a frequency, that's 20 hertz for a frequency. 2 for the number, 1 for the units. I think I can squeeze this last one on the screen here. The wavelength of a sound wave, if its frequency is 720 and the speed of sound is 360. Okay, so wavelength is going to be my speed divided by my frequency. So let's have a look. I've got my speed is 360. I've got my frequency is 720. 360 divided by 720 gives me 0.5, and because it's a wavelength, that's in meters. 0.5, 2 marks. Meters, 1 mark. Right, let me get the rest of the worksheet up on my screen here. Scroll down for that. Here we go. Oh, I think I can get all the rest of the questions on there, so we can get this done in 2 screens. Calculate the wavelength of a wave, which has a speed of 5 and a frequency of 15. Well, our wavelength is speed divided by frequency. Speed 5 divided by frequency 15 gives me 0.3 recurring, and it's a wavelength, so it's in meters. Bigger numbers coming up here. Calculate the frequency of a radio wave that travels at 300 million meters per second and has a wavelength of 1,500 meters. Looks like a big number, but I'll just let my calculator handle that. Right, frequency equals speed divided by wavelength. Speed, 300 million divided by wavelength, 1,500. And I'm going to have to pick up my calculator to do this one here. Can't quite do that, mental maths. Let's have a look. 300 million. Oh, get my calculator. 300 million. 300. 1, 2, 3, 4, 5, 6. 300 million divided by 1,500. It gives me 200,000. So 200,000. And because it's a frequency, that's in hertz. Capital H, little z. 2 for the number, 1 for the unit. We've got a radio station that broadcasts on a frequency of 125 kilohertz. They've got a speed of 300 millimeters per second. What's the wavelength? Okay, wavelength is speed, divide by frequency. My speed, 300 million. Divide by 125, but you may have spotted, this is the tricky one, this is in kilohertz. So it's not 125, it's 125,000. So that was what they're asking you to spot there. So instead of 300 million divided by 125, it's divided by 125,000. So that gives me an answer of 2,400. And it's a wavelength, so it's in meters. Now you get 1 mark for spotting that you needed to change it to 125,000, 2 marks for the right number, and 1 mark for the units. If you hadn't spotted the kilohertz, then you lose that mark, but as long as you did the rest of the sum right, then you'll still get the next 3 marks. What's the time period of this wave? The time period, remember, is time is 1 divided by the frequency. So it's 1 divided by, and our frequency again is 125,000. So it's 125,000 instead of 125. So 1 divided by 125,000. You do that on your scientific calculator, it'll give you 8 times 10 to the minus 6, and that's in seconds. So 1 for spotting it's 125,000, 2 for getting the right number on your calculator, and 1 for getting the seconds, which is the units correct. Quite a few bits of maths in there, but like we always say in physics, it's a brilliant way of picking up some quick marks in the exam. But that's the end of the lesson. There have been 3 parts of that there, so well done for getting all the way through to the end of the lesson. And I look forward to seeing you in the next video for the next waves lesson. All the best, guys.